Welcome, everybody. Now, these appliances are actually network devices. They're designed to make XML and web services deployments simpler, faster, and more secure. And this is actually a family of appliances. It starts with the XML Security Gateway, which is the entry-level variant of the DataPower family. It processes XML at wire speed with a set of security and policy enforcement functions. After the Security Gateway, we have the Integration Appliance. Now, this is IBM's hardware ESP. It's the core of the DataPower offering. It's built for simplified deployment and hardened security, and it includes all of the functionality that you find in the XML Security Gateway appliance, plus some added capabilities for bridging multiple protocols. After that, we have the B2B appliance. Now, that extends the capabilities of the Integration Appliance and adds business-to-business capabilities. So it adds digital certificates and the means for managing trading partner profiles. Now, in addition to these three principal variants of the DataPower family, we also have the Edge Appliance, which IBM calls an Edge of Network Traffic Gateway. Its principal function is it acts as a reverse proxy for web applications. And then we have a Caching Appliance that adds elastic caching, and that helps us get better scaling and improved application performance from industry applications. So, what makes these appliances so important? What are they good for? What are they useful for? Well, in a service-oriented architecture, applications are deployed through what we like to call loosely coupled services. And a big part of what makes that possible is the support of the XML markup language that's used for exchanging structured information, and also the web services that are built on top of that technology. So, the deployment of service-oriented architectures in most organizations introduces a lot of challenges. And one of the principal challenges is ease of use, because middleware services have multiple layers, and each one has its own specific configuration requirements. So, if you're doing upgrades, let's say, on one or more parts of this middleware stack, these upgrades actually have to be carefully coordinated so things don't fall out of sync. Another challenge is security. Now, as we mentioned, XML documents are important in SOA architectures, and when these documents are exchanged between business services, it actually presents a certain element of risk in the enterprise. So malicious XML can actually be injected into the middleware stack and compromise the security of the companies that deploy this kind of technology. And then there's performance. Now, performing parsing functions on XML is a very costly and time-intensive process. And all the mechanisms that one uses to make XML more secure makes those processes even more expensive. But most importantly, the DataPower Appliance introduces what we like to call protocol-independent, high-performance message processing. And what that means is the business services that you use can be accessed using different formats and protocols than the ones in which they were implemented. So one example would be the use of the DataPower Appliance to add, let's say, a web service front end to a legacy application. So let's say some incoming messages from client applications using SOAP over HTTP, for example, can be converted into, let's say, a copybook format, COBOL copybook over MQ for a back-end application running on a mainframe, just as one example. So there's a number of services that are provided by the IBM DataPower Appliances, and here's just a few examples of these. There's the XSL Accelerator, which validates and transforms XML. One example use case of that would be XML to HTML rendering, where XML is transformed from a back-end service to HTML on a web browser. There's a Web Application Firewall, which offers firewall services for standard HTML. It can be used to enforce security policies on data that flows between browsers and a back-end server. And it can ensure, for example, that specific form fields contain only certain values. The XML firewall that processes XML and non-XML payloads and adds actions to both inbound and outbound messages like data encryption or decryption. Or the multi-protocol gateway. Now, this builds on top of an XML firewall to add support for multiple protocols so that client-side and back-end services can communicate using different protocols. And finally, the web service proxy. Now, this provides the same services as the multi-protocol gateway, but it also delivers a web service front-end to back-end applications, and thereby provides better abstraction. So let's have a look at what these services do when they actually get started and start working. So when a DataPower appliance gets a message from a client, there's a whole sequence of events that happens before that message is forwarded to its destination. So first, the message is typically inspected and validated, and then it's sent to the service object, such as a multi-protocol gateway or an XML firewall, that's been configured for the specific IP address and port on which the message is received. Now, the next thing that happens is that this message passes on to the service's processing policy, which is a list of rules that contain a certain number of actions. Now, these actions are applied to a message according to specific conditions in a specific sequence. And then finally, the message is sent on to the back-end server. Now, when a response is received from that back-end server, the response is first validated. There's a processing policy that gets executed, and then the response is sent back to the originating client. Now, one of the interesting things about processing policies is that they can be configured to have different rules for request processing and for response processing. So here's an example of what a service processing policy for a multi-protocol gateway looks like. Now, a processing rule always starts with a match action that's followed by one or more processing actions. And the match action, it defines matching criteria to determine whether or not the incoming traffic, the incoming message, is allowed to be processed by different processing actions. So for example, an HTTP match action could be used to test the content of an HTTP header. Now, the processing action that comes next is, it really defines what happens to the incoming document. And there's a lot of different rules that are a lot of different actions that can be used. For example, there's filtering actions that either accept or reject messages, transform actions that transform XML using an XSLT style sheet, encryption, decryption, conditional actions, and results actions that forward results onto one or more remote servers.